Hi class. In this video we're going to do a little show and tell. I've got all kinds of computer parts in front of me from different eras, different types of input-output devices, memory. I've got some IoT type devices here, and I'm going to go over these. We'll discuss them, and you can use this information if you need to help you out with your current assignments. So first off, this is a motherboard for a late 90s computer. Let's see the date there, 1999. We'll start with the input and output. That's this back section here. These old plugs were for a mouse and a keyboard in that era. You'll recognize the USB ports. Now these ports here, these are a little different looking. So is this one. This is a parallel port. You could connect printers to it. You could connect external storage devices, either magnetic storage or CD-ROM. Now these plugs down here, these I think are, I think these might just be game ports. I'm thinking. I might be wrong. You know what, I'm going to say that these are serial ports. I don't know why I'd have two of them, but they let data go in and out on those pins. You can see this is made by Foxconn in Taiwan. So that's some of the I/O, just some of it on this. Other I/O, well, you have hard drives or floppy disk drives even. This could have both. These ports are for either a hard drive or for a CD or DVD player. The smaller one here is for a floppy disk drive. You've probably not used those. And there's more ports. This brown one is for a graphics card. These four white ones are for anything that will go in them. Sound cards, networking cards, you name it. It's a general input-output port. Same with these really long ones here. These are called ISA ports, and they supported older hardware in the 90s. They don't exist anymore. That doesn't exist. We use a different type of port for graphics and different plugs for other peripherals, which are just a fancy name for input-output devices. That is almost all the input-output on this board. There's surprising little things right here. I don't know if you'll be able to read it or not, but these little pins, one of them says speaker. That's what makes the computer beep. Gives you diagnostic information when it starts up if things are working right or not. A lot of interesting little ways you can get data in or out of a computer. Now, let's move on to memory. There's a surprising amount of different memory devices involved in a computer. It's not just the main memory. The main memory, by the way, goes in these slots here. It's called random access memory. So it's read-write memory. You could even think of it as a input-output type device, but it's for storage. It needs power, so it only maintains the data in it when the computer's on. Now, what other memory? Right here, this is a large integrated circuit. It's got 28 pins on it. They're on both sides. And it's from a company named Award. This is the BIOS chip. It's the basic input-output system. So if the computer is not hooked up to anything, no operating system, no hard drives or anything, you can still start it up and it will load this program automatically. So the BIOS is essentially the firmware for the computer, and it will get loaded up automatically if there's nothing else to load. Or you can load it up. You may have seen it or may have done it yourself, holding down like the delete key or the F12 key or whatever key it is for your particular computer. What that does is it puts the BIOS program into memory, and the computer starts running it from there. Now, this computer does not have a CPU on it. You might have thought that was the CPU, but it's not. That's a heatsink on top of the main chipset, I think. I think that's what's under it. I don't really know, because I can't, see under it. But I can show you the CPU. So this separate assembly with the fans on it and the circuit board under it has the CPU. You can see all the pins in there. That's one side of the CPU. It's a lot of pins. Okay. This is a slot style CPU. It actually goes in this slot right here. Just clips in. And then you plug in the fan so it gets power. Now the CPU has memory. This is a Pentium. This is a Pentium 3. Pentium 3 has cache memory. I think it has two types of cache memory, level 1 and level 2. Modern computers now have a third type of cache memory, and the latest processors from AMD have 3D cache memory. They're stacking memory on top of each other internally, making a matrix, a three-dimensional matrix of memory, and adding cache memory and better performance, because it makes it easier to send the electrical signals. Things are internally closer, and so operate faster. Now, so there's a lot of memory types, and then there's the storage memory, as we mentioned before. The hard drives, a rewritable CD storage, floppy drives, and you could hook up all kinds of other crazy devices to these slots. That probably could include some storage devices. I can't think of any offhand, but they would exist. So lots of different kinds of memory, lots of different types of input and output capabilities. Let's look at some memory right now. I can show you a few examples while these topics are fresh in your mind. This is a memory stick. It's not the right kind for this computer. You can tell because this one has little pegs in it that require cutouts in the memory board itself. And this one only has one cutout, and these slots here have two, so it wouldn't fit even though it looks like it might. This is 512 megabytes, which is not a lot in today's terms. There's 8 memory chips on it. There's none on the back side. It's single-sided. So each of these memory chips is 64 megabytes. Today, a typical single memory stick like this would have at least 8 gigabytes on it. And so either you'd have them like this, where each of these was 1 gigabyte, or they'd be double-sided and each would be 512 megabytes, and you'd have, 16 of them. So that's one type of memory. Other types you've probably seen. This is an SD card. This actually runs this little computer here. That's a Raspberry Pi 3. And this card is fast enough so that you can run, actually this is an adapter, and the card is even smaller. Let's see. That's the memory card. Not much bigger than a SIM card. And it has, wow, it has 16 gigabytes on it. And it's fast enough that you can run all the programs and software for the Raspberry Pi just using this card. Oop, I'll plug that back in later. Here's some more memory. Micro Center was just giving these away. This is a USB drive. (128 gigabytes). Yeah, 128. And it's USB 3.1, also known as USB-C. So if it's true, they don't always tell you the truth. It'd be really fast, really high data rate, a few mega or a few gigabytes per second. This, however, is what a hard drive looked like for this computer here. This has spinning discs in it, like records from a record player, and a whole stack of them. Takes power, takes a data cable. This is the circuitry that controls it. There's the motor is inside there for making it spin. Now let's see, how big is this one? I don't know. Oh wait, no, I do know. 320 gigabytes. That's what the sticker says. And that U133, that is a code for the speed of it. But I'll tell you, the speed, the real speed is like 20 megabytes per second. I mean, very different than these little cards and what a new computer can handle. Okay, so we looked at the CPU, we looked at memory. Let's look at some basic input-output devices that stick in these computers. So this is a graphics card that actually fits in this slot. It's an old card. This is made by NVIDIA. Doesn't need a lot of cooling. This is an aluminum heat sink. The GPU is underneath it, and it just passes, the heat is absorbed into the aluminum, and these fins just radiate the heat. It doesn't get too hot, so it doesn't need a fan. Nowadays the graphics cards need 2 or 3 fans. They're like that, except that the fans are 3 inches in diameter, so the cards are 9 inches to 12 inches long typically, because of the fans being so big. NVIDIA, by the way, was the first company to make an integrated GPU. Just a model or two before this one, the graphics card had multiple chips on it, and they put all of the components in one chip. They were able to miniaturize things and consolidate them into a single integrated circuit they called the GPU. These are the memory chips on it. Each one of those is 16 gigabytes, so it's a 32 megabytes, 32 megabytes in total. If you had 16 gigabytes, you'd be looking at a $2,000 graphics card. This now costs about $10 used. Oh wait, there's 4 of these, so actually these are 8 megabytes, I think, because this is only a 32 meg card. The plugs, some of those might look familiar. This is a regular audio video output that can plug into and the back of even some modern televisions. This is an S-video plug, same story, can plug into a TV. And then this is the VGA adapter, so that's for older monitors only that use VGA, so no high definition here. But it worked for a long time, worked just fine on these older computer systems. What else do I have? I haven't even opened this. This also is a computer card, and it plugs into, you can see it's got a notch in it there, one notch. It actually plugs into this PCI slot. And it is a sound card. This is a Sound Blaster card from the 90s. You could record, you could hook it up to your speakers, hook it up to headphones. And this port here, that is actually a joystick port. So you could plug in an old style joystick for computer gaming. And then there's some extra connections. And of course this is an input-output device, since it can record and it can play back. And that internally can hook up to several other things inside your computer. You can see CD in, auxiliary in, and this even had a CD digital audio format called SPDIF. So if you had a CD player in your computer, you'd plug the CD player into your sound card, and then whatever the sound card was hooked up to, the external speakers plugged in here, that's how you could listen to your CD player. And it was all integrated. It's made by Creative. And then the digital, it could send out digital audio as well, which is really pretty remarkable for the era. The yellow socket says digital audio on it. So you'd have to run that, since it was digital, you'd run it to a digital to analog converter, and then you can play your sound back. Today you can buy little boxes. I've got one downstairs. Imagine if this was in a box. It's about how big it is. You'd have a digital to analog converter in it, and you could plug in your digital music output, and it'd run through the converter out to a pair of speakers so you could hear your music. Okay. Now there's still one other plug I didn't cover on this, so I'm going to cover it just for the sake of completeness in case anyone's confused about what it might be. This is just the power plug. There's a lot of different voltages used by a computer, which is why there's so many sockets here, so many holes in the plug. The memory uses a different voltage than the graphic card, and the graphic card uses a different voltage than the CPU, and the hard drive and the floppy drive all use different voltages. There's I'm going to say there's 4 voltages, probably 3.3 volts, 5 volts, 12 volts, and negative 12 volts. That pretty much covers everything in the computer, because all these circuits, these integrated circuits, they all use 5 volts. Those are voltage regulators. Anyway, okay, so the last thing to talk about is really the IoT devices that I brought out. I brought out 2 of them. Let me get this memory card back in before I lose it. That was the problem. It only goes in properly one way. Now it's nice. Okay, so Raspberry Pi can be used as the brains of an IoT device, but it's also much more sophisticated. You may recognize this plug. That is actually a video output plug. The blue one is the audio output. USB plugs and a network connection. Now you wouldn't normally have need for all those on an IoT device, because they'd be even much smaller than this. Now you have storage, as we already went over, and this is the power plug. It runs on a regular old style 5-volt phone charger plug. Oh, and there's one more video output I should show you. HDMI. So this is pretty capable, much more than you'd need for IoT. But the Raspberry Pi is meant for more than that. Under this little heat sink, by the way, is the CPU. All of these pins, this is called the input-output header. So these are known in the parlance as GPIOs, General Purpose Input-Output Pins. So you can hook sensors up to these, and the sensor sends in a voltage signal, an analog signal, and the Raspberry Pi receives that signal and internally will convert it to a digital signal and send that information to whatever software is running, and that software will do whatever processing that it needs to do. Pretty nifty. The thing with the Raspberry Pi is it's got the sensor and the processing capability built into it. Some IoT devices, all they do is collect the data. They just collect it and then send it somewhere. They may convert it, right? They're going to convert the analog to digital, because basically all sensors are creating an analog signal, an analog voltage. Now, this next device, this is the last thing. This is a device that can be used for IoT. It still has some pretty big plugs on it for power. There's 2 different plugs you can use. This is also used for data, because that is a type of USB plug. So your programs get loaded into this, It doesn't have, well, it does have program memory, but it doesn't have any external storage capability. This chip here, the AT-Mega, that is actually a microcontroller. The silver thing here is the clock. It tells the microcontroller how fast to run. And then all of these sockets on both sides here, these are the input-output pins, just like on the Raspberry Pi. So there's digital pins, and there's some analog pins, and there's some pins you can get power from. And so you can hook this up to all kinds of sensors. It's pretty powerful. It is a 16-bit microcontroller, I believe. They're a lot of fun to play with. There's not much to them. And they're all over the world. A lot of different types of these too. Okay, that is the rundown. IoT, motherboards, devices, memory, storage, other peripherals. I hope this is helpful for you. Bye-bye.